Here we are starting with displacement diagram of a follower using simple harmonic motion. So here given the lift as 75 mm, the rise of the follower is 100 degree, that is the angle of ascent. Dwell at the maximum is 15 degree. Return of the follower is 120 degree, that is the angle of descent, and dwell at the minimum is 90 degree. So on the y-axis I have taken lift of the follower, that is maximum displacement, and on the x-axis I have taken the angle of rotation of the cam, that is 360 degree. Now I have to divide the following into the given sections. So rise, dwell, return, and again dwell. So I am dividing this. So the first section I have already divided. So the first section will be rise of the follower. Second section will be the dwell at maximum. Third section will be the return of the follower, and last section will be again dwell. So I will show the measurement. So this is the 100 degree, which is the rise of the follower. This is the dwell at maximum, which is 50 degree. 120 degree, that is return of the follower, and last one dwell at the minimum. Okay. So I am also writing it as this is the rise of the follower. This one is the dwell at maximum. This is the return of the follower, and last one is the dwell at the minimum. Okay, dwell at the minimum. Okay. Sorry. For simple harmonic motion, for drawing simple harmonic motion, we have to draw a semicircle at any of the ends. So for the rise, I am drawing the semicircle at this region. Drawing the semicircle at this region. So the radius of the semicircle, diameter of the semicircle will be 75. Now we have to divide the semicircle into n equal halves. The condition for dividing the semicircle is that here we are drawing the rise of the follower. So we have to divide this section. It is given as 100 degree. So it is suitable to divide this section into 5 equal halves. So if the section is divided into 5 equal halves, the semicircle is also needed to divide into 5 equal halves. So I am first dividing this section. So I have already divided. So one section will be 20 degree. I will draw the lines for I have divided the lines. I am showing these lines as thin lines. And start numbering. Numbering is an important factor. First one will be 0, 1, 2, 3, 4, 5. So I have divided the section, the rise section, into 5 equal halves. So I have to divide this semicircle also into 5 equal halves. So total angle of a semicircle is 180 degree. So I have divided each section will be of 36 degree. So I constructed it. You can see the section as 36 degree. Likewise, you have to construct the corresponding sections. Okay. So I am drawing in a simple way. You can use a protractor. Okay. Now I have divided the semicircle also into 5 equal sections. I am going to start numbering 0, 1, 2, 3, 4, and 5. Okay. check the numbering. Here the semicircle is ending at 5 and the right section is ending at 5. If the numbering is correct, all are okay. I'm showing this line as thin line. Now construct horizontal lines from each point on the semicircle meeting the vertical lines. Okay, so I am starting from 1, meeting at the vertical line of 1. From 2, meeting the vertical line of 2. From 3, meeting the vertical line of 3. From 4, meeting the vertical line of 4. 5, it's already there. So I am showing this as also as thin lines. Now number this intersection points as dash points. So this will be 1 dash, this will be 2 dash, this will be 3 dash, this will be 4 dash, and last one will be 5 dash. So this is for the rise of the follower, and we have to construct a graph for, passing through this point. Okay. So I have constructed the graph. So this is the graph for SHM for the rise. Okay. So I am showing after that that is the dwell period of 50 degree. That means the follower remains at maximum point till the end of 50 degree. So our graph will be starting from here till here. So I am showing this as a in red line. So we have reached this point. Okay. Now it's the return of the follower. How to draw a return graph for simple harmonic motion? Okay. So 120 degree. That is the angle of return. Similarly, here also we have to construct a semicircle. Okay. So here also we have to construct a semicircle. So I am constructing the semicircle on this side. You can construct anywhere. I am constructing it on the right side. Okay, because there is space on this side. It may be merging into the right section. So I am drawing the semicircle at this end. So I constructed the semicircle. Now the angle of the distance is, so the angle turn during the return is 120 degree. Okay, the angle turn during the return is 120 degree. So we have to divide this 120 degree into n equal halves. So it is possible to divide into 6. We can get 20 degree each section. So I am dividing this into 6 sections. So I have already divided. I am constructing the lines. I have done the division. So there are 1, 2, 3. Okay, 1 minute. So we will divide into 6. I have not done that. So now wait. Okay, I am dividing into 6 sections. Each section will be 20. Okay. Now I have divided into 6 sections. You can see first section is 20. Okay. Now construct vertical lines for each section. construct your vertical lines and showing this as thin lines. So here I have constructed 6 sections. So the semicircle also need to be divided into 6. So total angle is 180 degrees. So I have to divide 180 by 6. So each section will be 30 degrees. Okay. I'm drawing it as so each section will be 60 degree. I'm dividing. So each section will be 60 degree. You can check that. I'm taking a section. So it will be 30 degree. So there are 6 sections also. Okay. 6 section. I am showing it as thin lines. Now we have to number. The numbering is important. So we have end with 5. I am continuing the number. We will start with 6. Okay. So I'm starting here with 6, 7, 8, 9, 10, 11, and last point is 12. So while numbering for the return, you have to number from the top. So return means the follower is traveling from the maximum position to the minimum position. Okay, the follower is traveling from it has ended up to this point. Now it has to travel to the minimum point, that is it, to the 12. Okay, so for that we have to number from the maximum to the minimum to get a return flow. So the numbering here will be for the return starting from 6. This will be 6. This will be my 7. This will be 8. This will be 9. This will be 10. This will be 11. And the last one, it's 12. So for the rise, we have to number from bottom to top. And for the return, we have to number from top to the bottom. Top to the bottom means maximum displacement to minimum displacement. Now construct vertical line from each point on the semicircle. 6 already we have drawn. From 7, I am drawing a vertical line to the drawing a horizontal line, meet the vertical line of 7. From 8 to the vertical line of 8. From 9 to the vertical line of 9. From 10 to the vertical line of 10. From 11 to the vertical line of 11. Okay. So I have done the return also. I'm showing this as thin lines. Now we have to mark the curve using this point. Before that, I will start numbering. So this will be my 6 dash. This will be my 7 dash, 8 dash, 9 dash, 10 dash, and last point will be 11 dash. There will be 12 dash because it has already 12 dash is the minimum point. Now construct a curve passing through this point from the maximum to the minimum. So from 6, 7, 8, 9, 10, 11, 15, 12. So I constructed the curve. So the curve will be this one, which I am showing in red. That is for the return of the ball. For the rest region, it is the dwell at the minimum. So the curve will follow a minimum region, that is the dwell, which is also shown in red. So this is the graph for simple harmonic motion of a follower. Displacement diagram for simple harmonic motion of a follower. Okay. It started from 0 to the maximum, then a dwell to the minimum, then again a dwell. Okay. For rise, we have to number from minimum to maximum displacement. For return, we have to number from maximum to minimum displacement. That you have to keep in mind. Okay.